with a presentation by Rob Swartz with the RWA on the regional modeling effort. So Rob, I will hand that off to you, and you should be able to grab your, hit a share screen there and bring your presentation up. There you go. Floor is yours.
Okay, thank you. Good morning, everybody. Let me get to the right slide here. There we go. So I was asked to give some background on the modeling historically in the region to sort of set some of the context about the work that we're currently doing and still have to do over the next couple of years to arrive at our groundwater sustainability plans. So just a quick reminder for those of us that weren't involved at the initial beginning of this, is that the Water Forum, when we established these groundwater management areas, was really confined to Sacramento County. So you had the North Basin, Central Basin, and South Basin. And at the time, the process started in 1993. The county had recently completed a model in support of its general plan. And it's called SAC-IGSM, Sacramento County Integrated Groundwater Surface Water Model. And by today's standards, it was fairly crude, but by the standards then, it was absolutely state of the art. So we started at this point. We had these 31 what we call subregions identified in the model. And a subregion is very valuable because it serves as sort of an accounting mechanism. So when we think about water agencies and districts and such, they know what their water supply is like. So it enables us to look at water budgets and helps us when we're establishing the model to kind of determine some of its accuracy. So this was the model that was used for the Water Forum agreement that was executed in 2000. So fast forward a couple of decades, we now have a model called SAC-IRWM. So it's the Sacramento Integrated Regional Water Management Model. It has a slightly different modeling computer code that's been updated through time. And one of the notable inclusions at this time in 2011 is that we tacked on a portion now that the North American Subbasin, there was a model developed in the mid-1990s by the Bureau of Reclamation and DWR. So we basically linked up the two models. So now that we could be evaluating information, certainly in my part of the world where I work for Sacramento Groundwater Authority, in the entire North American Subbasin. When you link these models, it's fairly crude. They're basically talking back and forth. And so you do encounter some difficult boundary issues in modeling, but it's pretty good when you're modeling at a 30,000-foot scale. So some of the highlights of this model, it included almost 6,500 what we call elements. So each one of these little tiny well, not squares, but polygons that you see on there, those represent an element. And that's where the model is making calculations on water levels, pumping, and things like that. The average element size is about 140 acres, so about a quarter of a mile. So now we're really kind of refining. The original model was about a square mile. We're bringing in 2011 things like contamination at McClellan were very important. We really wanted to understand a lot more about our water budget and how much contribution we were getting from the American River in particular for the Sacramento Groundwater Authority. So we really refined the model around those areas to get a better understanding of that. And so now we're at a quarter mile spacing. We're up to 70 subregions. So we have much better accounting. We have more water district budgets included in there. It's a 3-layer model. And again, this is kind of crude. The third layer is actually below what we call the base of fresh water. So if you looked at this as a slice of cake in cross section, there are really only 2 model layers that are being simulated for groundwater. And so they're relatively crude in terms of that calibration. Again, a model is always developed based on what your computing power is. So they get more and more sophisticated, the more you can crunch numbers with a computer. The calibration period at the time covered 1970 to 2004. And we had 400 calibration wells in the model. So it was a pretty well calibrated model, had a pretty good understanding of the basin at the time. And it's been a very helpful tool for us. We've used this under many conditions to look at our water accounting framework that I'll talk about later, and defining conjunctive use goals in the region. We've even had some proposed development that has come forth over the years in the past and has used this model to understand what the impacts of development could be on the groundwater basin. So moving forward to about 3 years ago, we started having discussion about a really refined level of update to our model. And this was primarily driven by our discussion around a water bank. So, and again, I'm going to talk about that later this afternoon. These discussions actually started pre-Sigma, but certainly Sigma became a major driver for performing a model update. One of the responses that we would typically have 2 or 3 years ago when we talked to stakeholders, they said, we don't want to use that SAC IRWM. And we said, we're not going to use SAC IRWM. We are going to use the latest state-of-the-art model that the State Department of Water Resources is supporting. It's called IWFM. It's a new application, a very comprehensive tool. And what we like about it is that we know that the state has committed support through the Sigma program so that we know a decade from now or more, it's going to be available and supported and updated. And a variety of consultants are able to use the modeling tool as well. Now you can see, again, as I pointed out earlier, when you have new computer power, you can really update the refinement of a model. This one has 24,000 elements to it. The average element size now is 37 acres. So now we're down to a quarter section, or 1/16 of a mile. It has 86 subregions, and now it has 5 layers. And one of the big parts about that is the shallowmost layer is typically less than 100 feet thick, because we understand under Sigma, we really need to look at this surface water groundwater interaction issue. The calibration period has been updated to really reflect more recent hydrology. The last couple of decades have been substantially different than going back the previous few decades. And again, we have a higher level of calibration wells now available to us. We are working on this model in concert with the groundwater sustainability agencies, but also under the umbrella of the regional water authority. So I've been directing much of this because the model would support the water bank, but we've been having the individual subbasins really develop or drive the development of their model. So you can see that Cosumnes Subbasin has really been EKI, which is the primary consultant. We've been coordinating with them closely and turning over portions of the model to them to calibrate to a level of their own satisfaction. So we're very happy with the process that we've been doing. South American Subbasin is undergoing something very similar. In the North American Subbasin, we started ours first. We're nearing calibration. We expect it to be done in the next month or so, and so available as a tool. And the real advantage to doing this all together is that we can have common boundaries in particular. So I know there's been a lot of question about interbasin flow, and the American River and Cosumnes River are very important boundaries between the subbasins. And I think that with us all coordinating together, we can have a good, healthy discussion and an agreement that the tool was developed to all of our satisfaction so that we can accept the results. A couple other points about the model. We have several hundred M&I production wells. Those are shown in blue on the left. We have several hundred remediation extraction wells. Those are shown in red. Those are Aerojet and McClellan in particular. What we don't have is a lot of information on agricultural wells, because those have been private pumpers in the past. We have fairly limited information. You can see some dots up there in green in the upper left here, because these are individual agricultural production wells that have participated in some of the groundwater substitution transfers. So we have some decent information more recently on them. Otherwise, we really kind of count on the model, and that's the beauty of a model like this, is where you have unknowns, like independent agricultural pumping. You're actually using the model to establish what land use is, and therefore then what's the demand. We know about what the hydrology is. We know what precipitation falls. We know about surface water that's delivered. And then the model can then calculate for those unknowns about what sort of independent agricultural pumping is occurring. But just to let you know, as we proceed with these things, the level of detail and the confidence and the level of calibration is much greater in this more urban area shown in blue. And then finally, there's the locations of the calibration wells. You can see it's a little bit sparse in the Cosumnes Basin, but again, sometimes that's a function of simply how much groundwater is actually being used, particularly up here as you come into the foothills. So the uses of the model will be for GSP development. That's pretty obvious. There were a lot of questions, a lot of good questions, and the answers to a lot of those is we don't know yet. This model, once we have it done, we're going to be using that to develop comprehensive water budgets for each of these subbasins, sustainable yield estimates, establishing sustainable management criteria. And that's really going to be water levels, storage, and surface water groundwater interaction. This is not a water quality model, so we won't be using it for those purposes. we'll be able to look at future condition estimates. So we have an idea in each of these subbasins about what our future demands are estimated to be and what kind of land use changes we're expecting. But also we can superimpose that with a future climate hydrology. We'll be evaluating proposed management actions to the degree that a GSP identifies those. You can use the model for those purposes. And then finally, you can identify what some of these interbasin flows are so that the subbasins can be having those discussions as they develop their GSPs. Of course, for water bank development, we would be looking at that to evaluate our proposed operations. I'll describe again more about that this afternoon, but it would be a tool for us to evaluate what we can do today with our existing system, what we can do in the future with some minor modifications to the system, or major modifications in some cases, but of course then to use that to support an environmental analysis of that proposed water bank. So that's what I wanted to give us some background for the modeling tool. Happy to take any questions at this time.
Great, thanks so much, Rob. Let's open it up to any questions from folks. Either anything you want to clarify or something you want to better understand. Anybody have any questions looking in the chat? Ted.
Yes,
sure to unmute yourself.
Thank you.
Yeah.
Thanks, Rob, for a great presentation. In an earlier meeting, we had a conversation about climate change and the potential future impact on hydrology as a result. How does this model accept those potential changes and run them through various scenarios?
Great, good question, Ted. So what we would do is we'll run multiple scenarios. We'll run one with assumed future demands and current hydrology. Then we would run a second scenario with future demands and an assumed future hydrology. So will you be using a future climate data set? What we haven't determined yet is if we'll use the state provided future climate change, so they provide this hydrology that we can superimpose on the model, or if we're going to be able to use some of the better updated climate information that was provided by the American River Basin Study. So we're evaluating that right now. But that's how you would do it. You would actually run two different scenarios and look at what the difference would be associated with that future hydrology.
Great. Thanks, Rob.
Could I just follow up with that real quickly?
Yeah, please go ahead.
So what are the decision criteria, or will each individual GSA make this determination about whether to use the state data, which I understand is rather old and not as sophisticated, or the model that was presented to us? How will that decision be made?
Well, the first decision is going to be based on whether or not the information is actually available. And if it is available, then that would be up to the GSAs. And I think that we would coordinate with each other to make that determination. I would think it would be best if we're all using the same data set. But technically speaking, an agency could use their own data set.
So the availability of the data for use is basically well, I guess the issue of its release is currently in the Bureau's hands. Then when they finish their review, it would be subject to consideration for this process. Is that it?
Yeah, that's what I think. I have some questions out with some folks about the availability and when they might expect it to be available.
Thank you.
Thanks. Rob, just to follow up on that. So in theory, the model would run different scenarios, and then either the basin could choose which one to use, or in theory, GSAs could use whatever output they preferred. Is that what you're saying?
Correct.
Okay. Ron, see your hand again.
So what are model layers, and how does the model deal with perched or semi-perched groundwater?
So model layers, again, if you think about cutting through a layered cake, right, and you see multiple layers, that's what I'm defining as, right? So it's a slice through the aquifer system. There are different thicknesses associated with it. Should have shown a cross section. I just assumed we all knew that. But basically, those then, what they allow us to do is typically you have domestic well users, for example, are typically about 200 feet deep or less. Agricultural wells tend to be much deeper because they're looking for greater production. They might be 600 down to 1,000 feet. And a lot of times we see a lot of the municipal wells are in the 300 to 500 foot thick zone. So we really kind of define these different layers so that we can kind of see what the effects of the different types of pumping within the basin would be. I think that's sort of the simplest way that I would describe that. And I think you had a second part there.
Perched and semi-perched layers.
Yeah. So that's really complicated. It can handle it, but we don't have a lot of really good information on perched layers. We know that they exist out there, but they don't have a lot of contribution in terms of a water budget, right? So when we're talking Sigma, we're at a very high level. So, you know, we have to really kind of look at what the impacts of that would be. The way that it would be handled is again, as I described, this first model layer is about 100 feet thick. And one of the tricks that we use in modeling is to define a very low level of conductivity from layer 1 to layer 2. So to basically impede the movement of that shallow water into the deeper zone if we needed to simulate something like that.
I'll just observe that surface water resources such as trees and the like may be the beneficiaries of perched layers. And so, though it may not have a big impact on the overall mass balance, it may have a significant impact on surface ecological resources.
Yeah, and I think that a way that we're going to have to tackle that, Ron, is we're going to be going through and identifying the groundwater dependent ecosystems. And in a lot of cases, the riparian habitat that's being supported is not a perched layer, right? There's a connection with the river system. That will pick up pretty well. There may be areas, we experienced in this up in Placer County, near the Sacramento-Placer County line, that there is some perched water up there. But when you get below that perched water, it's 200 feet to the water table below that. So extraction that's occurring in the water table is not really affecting those perched layers. And so we'd have to evaluate those, and we tackle that in a different way than using the model, because I don't think it's going to be able to tell us things like that. There's a case where we might have to do some monitoring, right? Put in some shallow monitoring wells and really to understand it that way.
Great. I'm going to try to squeeze in one more question, but we need to shift in about 2 minutes here. Betsy, if you can put a quick question out there for Rob to answer, that'd be great. And you may be on mute, Betsy.
Okay. Yes. Could you describe future demands with land?
Sorry, Betsy, we're not hearing you. Can you get closer to your speaker?
Okay. Do you hear me now, Bennett?
Yes. Yes.
Okay.
Thank you.
Thank you. Could you describe how the future demands with land use changes, how that works? How is that going to be real time? Like someone proposes like Delta Shores or south of Highway 50, and you plug that into the model and do a real time estimate? Or is it something you're going to be forecast? How does that work?
Yeah, so what Sigma requires us to do is look out 50 years. So we're looking at general plans. So we're contemplating that everything that's currently identified, and again, in my case, just to be more specific, I'm in the North American Subbasin, so I also have portions of Placer and Sutter County. We're going to be looking at their general plans for what development they have out on the horizon. And when we run this model, we're going to assume all of that. So it kind of brackets those issues. What will be available is so that's what we have to do under Sigma. Ultimately, though, this can be a tool that would be available for specific development as it occurs in real time. So a project proponent, if you will, could pick this up and conduct an environmental analysis when that project's actually ready to move forward.
Great. Thanks, Rob. All right. Rob, I'm sure folks have more questions. And again, I invite folks to reach out to Rob directly or throw a question in the chat. I'll note that we've had a little bit of some comments in the chat around this issue of baseline that came up that Ron mentioned. And if we have some time later, it might be worth doubling back there. And I think there might still be a little bit of clarifying that might be helpful. But at this point, what I'd like to do is switch to the sub-basin specific presentation. And we'll start in the North American. So Rob, that's you and Jim, and then work our way south from there.
Great, thanks. Again, North American Subbasin, I love it. We call it the NASB. We do exist in parts of 3 counties. And again, these areas were not part of the water form agreement. We're working with 5 GSAs. We have the West Placer GSA, the South Sutter Water District GSA, the RD 1001 GSA, and the Sutter County GSA. And of course, Sacramento Groundwater Authority assumed the GSA role for Northern Sacramento County. We've been working very well together. We have agreed to prepare a single GSP for the entire basin. We have about $2 million worth of work that we're conducting, and it's being supported by a grant from the DWR to pay for about half of that. And SGA is acting as the lead agency in both GSP development and as the grant administrator. I want to give you some idea of current conditions. I know there were a lot of questions about that. These are some of the figures that we're starting to develop for the basin. We have a lot of long-term hydrographs, and this is a kind of interesting figure. It shows you all those locations, but it actually just gives you some representative hydrographs around the basin. And sort of the first thing that I think stands out, and something we've noticed for some time, and it's no big mystery for those of you that follow groundwater, it's sort of a tale of three regions in a basin. You know, your western areas along the Sacramento River have access to surface water rights. And so what you see in long-term hydrographs out there is water levels are pretty stable. Not a whole lot happening there. In the central areas where you don't have access to surface water, we've seen long-term declines through time, and we've seen some stabilization there. And one of the things I want to point out is there is a slight distinction between what's happened in the Sutter Placer area and what's happening in the Sacramento groundwater area, and that's in this hydrograph up here, is that we all experienced overdraft. But up in Sutter County, they were experiencing the overdraft, and here in the early 1960s, South Sutter Water District completed Camp Bar West Reservoir up on the Bear River to help alleviate some of those issues. So they started actually back in 1964, I believe, the reservoir became operational, and you started to see the water levels increasing and have been fairly stable. They had some pretty significant issues during the drought, but we can see that they have since recovered. So really there was very little access to surface water in those times. Whereas in Sacramento County, we continued to experience that overdraft into the mid-1990s. We hit our low in 1992 at the tail end of the 87 and 92 drought, but really then started practicing conjunctive use. Thanks Sacramento Suburban Water District, Placer County Water Agency, working together there as part of the agreement here in the water form agreement to really start taking surface water in that north service area. And you can see that we've stabilized water elevations. And then finally in the east, again, a similar situation here, but here geology plays a part. You're up near the foothills and you have access to surface water. So being near the foothills, you don't have a lot of good groundwater basin to rely on, but also being near here, you're able to get surface water. So again, in the eastern area, we tend to see very flat, sort of static water elevations. If we look at contour maps, we can kind of get a picture here for how the basin has changed through time. How has it been behaving over the last couple of decades? So on left is a contour map showing a pretty extensive cone of depression centered right around McClellan. And we can see here that the lowest elevation we experience is 47 feet below sea level, minus 47. Fast forward to 2017, just coming out of the drought, this low elevation at that same well around McClellan is 34 feet. So even coming out of the drought, most extensive drought that we've had, water elevations in the cone of depression have recovered by about 13 feet. And we're continuing to see that. So we do like to think that the actions that have been taken through the conjunctive use program over the last couple of decades associated with the water form agreement have been very beneficial to this part of the world. Drilling down a little bit deeper into the Sacramento Groundwater Authority, these are from the M&I purveyors, so this doesn't include agriculture, it doesn't include the extractions for remediation water, but that reported by the agencies to participate with Sacramento Groundwater Authority. You can actually see on a decadal basis, we've had an average groundwater reduction from up near around 100,000 in the 1990s, came down to below 90,000 in the early 2000s. And since 2010, is now less than 70,000 acre-feet on average. And what we're seeing is we just see annual variations to better match up with the hydrology. So we're seeing a conjunctive use program. And again, more highlighted graphic here, the hydrograph, this taken up in, near McClellan again, that center to the cone of depression. We've had great recoveries. You know, we were drawing water levels down by a couple feet per year. We've since recovered by about a half a foot per year, and even moving through the drought, we didn't really see anything very substantial happen to the basin, and we've since recovered. One of the questions has been about surface water groundwater interaction. And what I can tell you right now is we don't have the answers, but we've certainly been collecting a lot of data. This graphic here gives us an opportunity to show some of the new work that we've done under Sigma. And these squares here that are in orange show you new monitoring wells that we have constructed that are dedicated to understanding what's happening in the deep portions of the basin, but also along some of the rivers that we really didn't have a good understanding. So in the North American Subbasin, of course, we have the Bear River, the Feather River, the Sacramento, and the American. So we're really trying to define what that looks like. Fortunately, we had a lot of wells that were drilled by Safeco, and they gave us access, you know, for flood control purposes. They gave us access to a lot of those wells, and we were able to instrument those as part of our grant, the transducers. So what we're able to do is these gray dots are stream gauge locations where we have data on each of these rivers, and we're able to compare that then to what do groundwater levels look in the wells nearby. So we can see up on the Feather River, there's a very close relationship between Feather River flow shown in blue and the green line, which is the nearest well to that. So we can see at times the elevation of the groundwater is actually greater, so it's potentially contributing to the river. There are times where it goes below, and so that relationship just changes sort of throughout time. And again, as we collect more information, then we'll be able to say a whole lot more about that. We're seeing a similar situation down here on the flow gauge near Verona in one of the Safeco wells. Up along the Bear River, and we've known this for some time, that the Bear is consistently a losing river. Groundwater levels are below what we would see out in the flows, but you can see a relationship. You can see that response. When Bear River flows increase, we see the increase in the groundwater basin. And finally here, SGA 4, that's down at the Sac Suburban's Enterprise facility, we're able to use the H Street gauge and compare that to a transducer that we've installed in that well. And we can see that there's a very strong response, again, not unexpected. As the river flows go up, they're feeding into the groundwater basin, but we can see that these elevations are consistently a little bit below the American River at that location. So there's a lot more to be learned about this, but just to let you know, we're putting in a lot of monitoring, and we'll be able to feed a lot of this monitoring information into the model, and then be able to answer a lot more of your questions about surface water and groundwater interaction in the future. As far as groundwater quality goes, it's no secret that we have some of the most substantial contamination anywhere in the country due to our former defense activities in the form of Aerojet and Mather and McClellan. But we've been very active in working with those responsible parties for the last 15 years. Sacramento Groundwater Authority originally started a committee actually with the Water Forum called the Regional Contamination Issues Committee, because we wanted to get a better understanding about how this contamination could affect the Water Forum agreement back at that time. And it was really kind of spawned by the 2004 discovery of the contamination from Aerojet moving under and being detected into Carmichael. So that was a great concern. But a question that was asked is about these cones of depression. And do we have intent to fill them up, if you will? And my initial response at this time is no. There's actually an advantage to having the cones of depression. We've been working very closely with McClellan. Many of you are familiar that they have two forms of contamination. They have vadose zone, or the unsaturated zone contamination, and then they have a groundwater remediation program as well. And those are two separate systems that are optimized, and they were based on the assumption that water levels would be where they were. And it's basically in our interest to maintain water elevations around McClellan in particular at those levels, so they can clean that up to the benefit of the basin. You can also see the conjunctive use program that I showed you. Those stable water levels have actually been very favorable to include, getting us through the drought. We've also used a model to evaluate whether or not our conjunctive use operations would move these plumes. And we found that there really isn't any movement. The agencies that are responsible for McClellan and Aerojet in particular have done a very good job with their capture systems. And if you remember one of my previous slides, I showed you all those red dots. We actually have those in our model, and they're able to contain that plume even while we're out operating in our conjunctive use fashion. And again, why it's not in our interest to try to fill up the basin and to change those conditions. One of the final topics would be subsidence. I'll try to move through here pretty quickly, but we have a lot of information about subsidence. We have been up here on the upper right. These are land surface elevations taken from a benchmark up around Citrus Heights from back in 1947 and taken again in 1990. And what it's showing, so the subsidence is on the right. What we're seeing is that we had about 2.2 feet of total subsidence. What we also have are 2 hydrographs from wells up right near that benchmark. And we can see as those groundwater levels were going down during the overdraft period, there we go, we can see that the subsidence was occurring. So those are not very substantial amounts of subsidence compared to what you might see elsewhere. And you can also see then since that time, we have been bringing water elevations up. So we believe that if we continue to operate the way that we have been, we don't think subsidence is going to be a major issue in our area. We also have a dedicated well in Sutter County called an extensometer that measures directly subsidence. And it's hard to see the scale here, but we're talking about hundredths of a foot of subsidence that has occurred, very little. And finally, DWR created a valley-wide network that they measured in 2008 and again in 2017. So coming at the heels of the drought, and I understand it's a very difficult figure for you all to see on the left-hand side, but basically these dots on here and the fact that they're clear indicate there was really no detectable subsidence occurring in our basin, even before we've recovered fully from the effects of the drought. We can see that we do see subsidence out in Yolo County and up in Zamora, which again is what we would expected. So subsidence is not a major issue. So let me wrap this up in terms of what do we see as being some of the major issues around the sustainable management criteria. Obviously, I think subsidence, I'm very comfortable saying it is not and will not be a concern for us in the future. Very comfortable saying seawater intrusion is not and will not be. The remaining, we still have a lot of technical work to do. So I've shown you that we have addressed groundwater levels, we've addressed storage, we've addressed groundwater quality degradation. We have a good understanding of that. And really what we're gonna have to do is run the model and look at these future conditions to provide the assurances that that is going to continue to be the case. But as of today, we feel very comfortable with our current conditions about our sustainability indicators, and we don't currently see any that really kind of rise as a true red flag.
Great, thanks Rob very much.